Salam and welcome everyone. So today we're going to be working on the question on the screen that says, using the van der Waals equation, calculate the pressure of a sample containing 3.5 moles of krypton in a 2500 dm cube container at 350 Kelvin. Van der Waals parameters for krypton is simply A is equal to 0.23 Newton meter raised to the power of 4 per mole squared, and then the value for B, which is 39.8 times 10 raised to the power of negative 6 meter cube per mole. So these are the A and the B are the values for the van der Waals parameters, where B value is the value for excluded volume, and then where A value is the value for like strength of attraction. So that's just basically what each one of them means. The parameter A, like I said, strength of attraction, that's what it measures, and then B measures the excluded volume. Now, I wanted to also mention something that when you have a question like this, you would have to first of all write all of the parameters. You write all the parameters that you need before you start solving, and you should understand the question very, very well. Again, this is physical chemistry. You have to be very careful because you're going to be dealing with a lot of information. So, the first thing I wanted to mention is we're told to calculate the pressure of a sample. So, P is what we're looking for, containing 3.5 mole of krypton. Then we've been given the number of moles to be 3.50 mole. Sorry, I forgot to add that. It's 3.50. And then we were told the volume in a 2,500 decimeter cube container. So the volume is just 2,500 decimeter cube. And the container, the temperature is, the whole situation is occurring at the temperature of 350 Kelvin. Van der Waals parameter for krypton, A is equals to 0.235 Newton meter raised to the power of 4 per mole squared, and B is equals to 39.8 times 10 raised to the power of negative 6 meter cube, nothing like Newton, sorry, meter cube per mole. Anyways, so we have that. We're told to use the Van der Waals equation of state to solve this. So the Van der Waals equation of state is actually pressure is equal to RT divided by V sub M minus B minus A is equals to V sub M squared. So that's basically what this is. Where we already know the value for temperature because we've been given. We know the value for A, we know the value for B, but I'm sure you'll be wondering, well, this is volume here and this is Vm or V sub M. V sub M is simply just the molar volume. And what the molar volume is saying is just this here. Molar volume is just simply volume divided by number of moles. So V sub M becomes 2,500, okay? 2,500, okay? Divided by 3.5. So 2,500 decimeter cube and 3.50 mole. So yeah, that's basically what this will be. So all in all, we have the value for V sub M. And of course, we can just square that. So we have that. So the only thing we don't actually have that we're not given is R. And as you're aware, R is the gas constant, right? Gas constant is just simply R. And you can get two types of gas constant or two different values. You can either get 0.08 to 06, okay, or you can have R is 8.3145. So in this question, you're going to be thinking, which one am I supposed to use? Well, the 0.08 to 06, we tend to use that anytime we're dealing with like decimeter cube, atmospheric pressure, or what they call it. Yeah, if you're trying to deal with decimeter cube, atmospheric pressure, and things like that. But whenever you're dealing with 8.3145, you tend to be dealing with Pascal or Newton per meter squared. You tend to be dealing with meter cube. So when we look at the value for A and B that we're given, we will see that we have Newton meter raised to the power of 4, okay? And then here we have meter cube per mole. So I'm going to stick to using 8.3145 because the units are it's gonna be easier for us to match. But then you can be wondering, like, why is it that we have 2,500 decimeter cube? Why can't we use that? It's because the value for A and for B tend to have meters. So we're actually gonna need to convert this volume right here from decimeter cube to meter cube purposely. We have to do it because if you want to convert from meter cube to decimeter cube, we are going to make our work so much more complicated, and physical chemistry is already complicated enough. So we have to pick whatever is easier. So even here that I have 2,500, dm cube, okay, divided by 3.5 per mole. I'm only using this information here to explain it. I actually would prefer to convert from 2500 decimeter cube to meter cube, and then I'm going to use whatever that value is and divide it by 3.5 to get the molar volume. That's what I prefer to do. But going back to this value here, our gas constant 8.3145 is going to take the units meter cube, Pascal per mole Kelvin. I also wanted to mention something to you guys. Please and please, if you're confused about gas constant or you want to know more about gas constant and their different units, just Google gas constant and their different units, because you play with the units a lot. Sometimes you can get the units to be kilopascal here, and then maybe you have dm cube here, or you could have dm cube here, and of course atmosphere, or you could have dm cube, sorry, or you have liters, atmosphere. So really, when you go and you Google it, you're going to see that all of this gas constant, even though the value can only be 8.3145 or 0.08206, know that the units can vary depending on whatever you need it to be in order for you to solve the question. So we need the 8.3145 meter cube Pascal. And don't forget what Pascal is. Pascal is Newton per meter squared. Don't forget Pascal is the formula, is the units for pressure, and pressure is just simply force over area. So hence Newton per meter squared. So don't forget that's what this is, by the way. Newton per meter squared. But yeah, that's it. You're going to need to know this information well. Anyways, going forward, let's remember that this is all information that we need. We've successfully gotten all the parameters: the temperature, the molar volume, the value for B, the value for A, and now the value for R. Now I'm going to calculate the information for molar volume. So for molar volume, we're going from 2500 decimeter cube to meter cube. So that would be 1 meter cube divided by 1000 decimeter cube times 2500 decimeter cube. So that's it. You cancel out the decimeter cube here, cancel out the decimeter cube. 2500 divided by 1000 is just simply 2.500 meter cube. So that's basically what this is. Now, 2.5 is, sorry, not the volume. Yeah, this is just the volume, sorry, not the molar volume. Now we're going to go from volume to molar volume. So that's just going to be molar volume is equals to V over N, where it's going to be 2.500 meter cube divided by the number of moles, which is just simply 3.50. So that's 3.50 mole. So of course, you input this information in your calculator to get 0.71429 meter cube per mole. So yeah, that's it. Now the next thing you do is you've gotten all your parameters, you just have to simply substitute. And by the way, if you're confused about the way I'm solving this, please just rewatch this video. Yeah, rewatch the video. Fully everything works out. So RT is equal to molar volume minus B minus A divided by molar volume squared. So P is equal to, the value for R is just 8.3145 meter cube Pascal divided by mole Kelvin times temperature, which is just 350 Kelvin, divided by V sub M. So yeah, V sub M minus B. So V sub M, let's not forget what that is. The molar volume is 0.714. Let me not put 29, let me just put 3 meter cube per mole, okay, minus the value for B, which is just simply, the value for B is 39.8 times 10 to the power of negative 6 meter cube per mole. So 39.6 times 10 raised to the power of negative 6 meter cube per mole. And we know that we are on the right track because these two units actually match: meter cube per mole at the denominator and meter cube per mole at the denominator for both sides of the negative. So that's it. So minus what would have been, yeah, minus the value for A. So the value for A is 0.235 Newton meter raised to the power of 4 per mole squared. So 0.235 Newton meter raised to the power of 4, okay, per mole squared, okay, divided by 0.7143 meter cube per mole all squared. So yeah, that's it. Of course, we can start working towards cancel stuff out. On this side, we can cancel out Kelvin here, cancel out Kelvin here. That's all that we can cancel out for now. So let's go to the next line. So P is equal to 8.3145 meter cube. And then you've got Newton per meter squared. Because I'm going I'm going to rewrite the Pascal to just be Newton per meter squared since we don't have any other Pascal, but we have Newton on the right side of the negative. So I'm just going to rewrite all of that out per mole. So per mole, okay, times 350 divided by 0.7143 minus 39.6 times 10 to the power of negative 6 will end up giving you 0.714260, of course, meter cube per mole, okay, minus 0.235 Newton meter raised to the power of 4 per mole squared divided by 0.7143 all squared is just going to give you 0.51022245. And then, of course, of course, meter cube squared will just give you meter raised to the power of 6, and then per mole squared. So you cancel out the mole squared here, cancel out the mole squared here, cancel out this meter raised to the power of 4, cancel out the meter raised to the power of 6 to meter squared. Um, Cancel out the meter cube here, cancel out the meter cube here, cancel out the moles here, cancel out the moles here. So yeah, that's basically what we have so far. So yeah, that's it. So now we've canceled out all the units, or as much unit as we're supposed to cancel out. What we have here that is left is just Newton per meter squared. And then you have Newton here, and then you have meter squared here at the bottom. But everything else in terms of units have been canceled out. So we can do further calculation. So you have pressure is just going to, I'm going to rewrite this so that our work is neat. 8.3145 times 350 Newton per meter squared, okay, divided by 0.71426, and then minus 0.235, okay, divided by 0.51022245. And of course, you've got Newton here and meter squared. So Newton per meter squared. So yeah, that's it. So pressure is up to come 8.3145 times 350 would just give you 2910, okay, 2910.075, okay, Newton per meter squared divided by 0.714262, yeah, minus 0.235 divided by 0.51022245. I don't have to rewrite that. I can just say 0.460582 Newton per meter squared. We input 2910.075 divided by 0.714262, and that's just going to give you 4074.25053 Newton per meter squared minus 0.460582 Newton per meter squared. Let's not forget Newton per meter squared is the same thing as Pascal. So I'm just going to write it in Pascal form. So pressure ends up becoming this information here minus this information here. So when you do the subtraction, you end up getting 4,073.78995 Pascal. And then, of course, we know that we're chemists. We have to put our work in the proper number of significant figures. And let's go back to the question. We see that we have this 3.50 more in 3 sig figs. Okay, so this is 3 sig figs here. This is 4 sig figs. This is 3 sig figs, 3 sig figs, 3 sig figs. So we're going to put our answer in the proper number of significant figures, which is just 3 significant figures. So when we do that, we end up getting this one here. So we have to write this in a form where we're doing our work correctly. So pressure ends up becoming 4.07 times 10 raised to the power of 3 Pascal, or we can just say pressure ends up becoming 4.07 kilopascal. So that's basically the answer to this question. So yeah, that's the value for pressure. Yeah. So and I wanted to quickly mention that this question isn't from the Asking School Chemistry 11th edition. This is actually a question from one of my students who needed help. And during one of our sessions, I did this question or solved this question and explained it. I tried to go into detail, a lot more detail than some of you might have liked, but the goal is for you guys to succeed. So yeah, if you're confused, please rewatch the video. If you like to give any suggestions or you have any concerns or you have any questions, put in the comment section and I'll do my best to respond to you. I also wanted to mention that if you're a student who is trying to succeed in any of your STEM related courses, please email me at shohabitutoring@gmail.com. I help students that are struggling and also students that are striving to succeed in all their STEM related courses, as well as I mentor students as they progress through academia. So if you'd like me to tutor you and you enjoy the way I explain things, I would appreciate it if you can email me and then we can book a session. Just like I've said, this is actually a question from one of the sessions that I had. So yeah, that's about it. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.